Hello again. So, division is more complicated than multiplication. So, if the derivative of a product is not the product of the derivatives, it's probably too much to hope that the derivative of a quotient be the quotient of the derivatives. And of course, that is not true. So, hot on the heels of the product rule, there's another rule that we unfortunately need you to look at, the quotient rule. So, the derivative of a quotient, the derivative of u divided by v is, let me think. We take the derivative of u, the derivative of the top, we multiply it by the bottom. We leave the bottom alone. We leave the top alone and we take the derivative of the bottom. So far, very much like the product rule, except that we subtract these instead of adding them. And in the denominator, we don't take any derivatives at all. We square the denominator of the original function. So the derivative of u over v is u prime v minus uv prime over v squared. And let's do an example. So let's pick something from a different discipline, since we looked at demand functions a little when we talked about the product rule. Let's look a little at medicine. So drug concentration curves often end up looking something like this. C of x equals a number times x divided by a number times x squared plus a number. So we'll use 2x divided by 5x squared plus 2. And the reason equations like this show up is simply that they have the shape that we expect a drug concentration curve to have. So here the input is the time since a drug was administered, and the output is the concentration of the drug in the bloodstream. And if we just try to think out what this graph should look like, well, initially, we should start at the origin. Initially, there is no drug in your bloodstream. As the drug passes through your cell walls, the concentration should go up, but eventually your body should flush the drug out, and the concentration should go back down, something like that. And if we just go to Desmos briefly, let me increase X. Maybe I increased it a little too much. But if we look at this graph on Desmos, of course, time has to be positive. It does what we want it to do. Concentration starts at 0, it goes up with time, then it decreases as the drug is flushed out of your bloodstream. And of course, this is a quotient. So if I ask a question, after 2 hours, how is the concentration changing? Well, I want to know C prime of 2, and to find C prime of 2, I need C prime of x, and then I'll take 2 and I'll plug it in. So to take C prime of x, of course, this is a quotient, so we need the quotient rule. And let me copy C of x down here, just so that I'm not constantly shifting this notebook around. The quotient rule says, take the derivative of the top. The derivative of 2x is 2. Multiply it by the bottom. 5x squared plus 2. Then take the derivative of the bottom. I hope we can do this fairly quickly by now. We're using the power rule on the 5x squared. The derivative of the 2 is 0. So the derivative of the bottom is 10x. And we're multiplying it by the top. And then we're subtracting those. So 2 times 5x squared plus 2 minus 2x times 10x. And then the denominator, we are not taking any derivatives, but we are squaring it. 5x squared plus 2, that quantity squared. And this, I've gone on record as saying that I think simplification can be kind of subjective. I mean, in the sense that what a simplified answer looks like sort of depends on what you want it for. But I think it would be hard to argue that the top of this fraction is not messy. So let's just, this is going to be 10x squared minus 20x squared minus 10x squared, and then 2 plus times 2, 4. The bottom I'll leave factored. And here is the derivative. And my grammar got kind of convoluted. Sometimes it's not clear what simplification means. Like, should you FOIL the bottom out or should you leave it factored? I don't know. It depends. But clearly, we have simplified the top. I think that verges on objective, that this looks nicer than that. Then C prime of 2, let's see, negative 40 plus 4. 2 squared is 4 times negative 10 is negative 40 plus 4, negative 36. Let's see. 2 squared is 4 times 5 is 20 plus 2 is 22. 22 squared is 484. For word problems, I usually give decimal answers. I was saying you're going to. You should have already seen this in the quizzes, right? I asked you to give your answers as decimals, rounded to however many decimal places. So let me just real quick. 36 divided by 484. 0.074. And let me see. The output is a concentration, so I suppose we'll just call that percent, although the real unit's a little more convoluted. Time, we can say, is measured in hours. So this is minus 0.074% per hour. And there's the quotient rule. And just like the product rule, it's messy, but just like the product rule, you've got to learn it. There's no choice. So I always feel sort of bad dumping both of these on you in the same section, but this is how pretty much every textbook handles it.